Hello everyone. Today in this PPT we will be studying about Unit 2 transducer. We will be continuing the lecture series, that is lecture number 8, last lecture from this. We will be completing this chapter. It is from the subject electronic measurements and instrumentation. So contents: capacitor proximity sensor, then inductive proximity sensor, then pneumatic sensors, then digital optical encoders, then PIR sensors, and at last we will be seeing the summary. Then next one, capacitance proximity sensors. So figure below you can see the capacitive proximity sensor. Capacitive proximity sensor detect changes in the capacitance between the sensing object and the sensor. So there is a sensing object and the sensor, between that it will be seeing the detecting the changes in the capacitance. Okay. So the amount of capacitance varies depending on the size and distance of the sensing object. So the capacitance varies depending on the size of the sensing object. Okay. As the sensing object size will be changed, then the capacitance will be varied. Like this capacitive proximity sensor will be working. The next one, inductive proximity sensor. Here you can see the diagram. The coil figure here, coil is wound around a core. Okay, around the core the coil is wound, that is inductive coil it is called. When the end of the inductive coil is close to a metal object, you can see there metal object, its inductance will change. So this inductive coil, when it will be close to the metal object, then the inductive will be changed. So the we will be changing the distance between the metal. Okay, then it will be changing the inductance. This change can be monitored by its effect on a oscillator circuit. So you are giving it to an oscillator circuit, and this change is used to trigger a switch. So due to the change in the distance between the metal and the inductive coil, you will be triggering the switch. Okay, so like this inductive proximity sensor will be working, switch on and off. The next one, pneumatic sensors. So pneumatic sensors are used to measure displacement as well as senses the object close to it. Okay, the displacement and proximity are transformed into change in air pressure over here. So you can see below figure the diagram of an pneumatic sensor. So here what it is, the displacement and the proximity are transferred into the change in the air pressure. So the object is over here, escaping air increases pressure in the system. Okay, so here air dragged out of the port, and so drop in the system pressure will be there. So you can see the port A and port B. Rise in the pressure, what will happen, the object blocking escaping air increases pressure in the system. Okay, then next, digital optical encoder. The digital optical encoder is a device that converts motion into a sequence of digital pulses. So encoders have both linear and rotary configuration, but most common type is rotary. Okay, rotary encoders are manufactured in two basic forms. First one, absolute encoder, where a unique digital word corresponds to each rotational position of this shaft. The incremental encoder, which produces digital pulses as the shaft rotates. So first one, as I told you, that is so you can see the figure of it. So rotary encoder consists of a glass or plastic code disc with photographically deposited radial lines. Okay, as radial lines in each tract interrupt the beam between the photoemitter detector pair and digital pulses are produced. Rotary type encoders are more common and are of two forms: absolute encoder and incremental encoder. Okay, so as I told you, it will be consisting of comprising a disc with three concrete tracks of equally spaced holes. Three light sensors are employed to detect the light passing through the holes. Okay, then next, PIR sensors. So PIR sensors, what are these? All objects with a temperature above absolute zero emit heat energy in the form of infrared radiation, which is visible, that is invisible to the human eye. Okay, so the radiation isn't, that is it is invisible to the human eye. So a passive infrared sensor, that is PIR sensor, is an electronic sensor that measures infrared light radiation from the objects. Okay, so passive infrared is an electronic sensor. What it will do, it will measure infrared light radiation from the objects in its field of view, means where in its sight. Okay, they only detect the infrared radiation emitted or reflected by the other objects, hence they are called passive sensors. They are used in motion detectors. Okay, the next summary: capacitive transistors operate on the principle of what? Variation of overlapping area of plates, then variation of separation of plates, then variation of reflective permeability of dielectric material between two plates. A digital optical encoder is a device that converts what? Linear or rotary motion into a sequence of digital pulses. By this we are completing this chapter. Thank you.